out of the packet? Out of the packet. It's in the packet.
It's in or out of the packet?
Okay. I think you're going to find this is on page 341. And quit purposely making it make noise. Yes. It should have been down in the first place. $341. The table shows the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. If they're talking about a rate of change, they are, in fact, talking about a slope. Anytime you're dealing with a rate of change, that is what specifically they're talking about. If I want to decide whether the rate of change is constant or variable, I actually have to calculate the slope between each set of ordered pairs. Okay? X always comes first in a table. So X is your time and Y is your height. By the way, X is independent. In other words, X can be anything time-wise. Y is determined by, in other words, it's dependent upon what? X. Okay? Now, with that being said, to calculate the slope of this first one, what would I do? 18 minus 0 over 0.5 minus 0, which is 18 over 0.5 or 36. Okay? Everybody with me on the slope of this first pair? Right? Good? The second pair would be 31 minus 18 over 1.5 minus 0.5. (13 over 1, which is 13. At this point, do I have to go any further? Is it constant?
Or not?
It's definitely variable. And I want you to understand what it would look like on a graph then. Would this be a straight line?
No.
No. In fact, it would be pretty steep. If it had a slope of 36, it'd be pretty steep. And then it would get less steep, wouldn't it? Question? Everybody understand that some of the questions that you're going to have are going to ask whether it's constant or variable, and to determine that, you have to find each of the slopes. Everybody get it?
Yeah.
Turn the page. I really don't like problems where they half worked them out, because I find that people struggle more with these because they've stepped through part of it and they want you to follow the rest of it that they've kind of laid out for you. I find that people usually do better if they're just doing it completely on their own. So let's talk about it. Part A, it says, find the rate of change from 1 hour to 2 hours. Well, if I come over to my graph, 1 hour was at 1:15. 2 hours is at 2:30. So, using the formula, it's going to go from 30 minus what? Minus 15, y2 minus y1, over x2 minus x1, 2 minus 1. And this is going to be 15 over 1, which is what? 15. They're actually going to have us do it several times. I'm going to do one more. They said from 1 hour to 4 hours. What's the two ordered pairs? 1 hour is what? 1 and 15. 4 and 60. So what do we see? 60 minus 15. 4 minus 1. 45 divided by, which is what? 15. Okay. So, I'm going to tell you on all of these that the miles per hour is going to come up to what? 15. Listen, is this a proportional relationship or not?
Yes, it is.
How can I tell for sure? Right. It's a straight line and it goes through what? 0, 0, the origin. I want you to see that if it goes through the origin, there's a quicker way to get this slope. Y over x. 15 over 1 is, 30 over 2 is, 45 over 3 is, 60 over 4 is. Does everybody see if it goes through the origin that I can use this and I'm still going to end up with that same rate, 15 miles per hour? Okay? Are you okay? Now, if you look at the next page, I want to talk about the notation that's here. Where it says rise, right above where it says rise, would you write y2 minus y1, please? And where it says run, what do you think we're going to put? There are so many people that teach that slope is rise over run. And it is. In fact, it is. I could count how much it goes up, that's the rise, or down. And I could count how much it goes left to right, that's the run. Okay? But I can always use the formula. Okay? And if you get used to using the formula, and you get used to the notation that's in the formula, it's going to help you when you start dealing with midpoint and distance, because the notation of those formulas are going to look the same. There's going to be two x values, so it's going to say x1 and x2. There's going to be two y values. It's going to say y1 and y2. So if you get used to the notation now, it's going to make that process easier. For rise over run, you need a graph, or you need to know what? That rise means y2 minus y1. Well, then you're learning the formula anyway, right? Why not just learn what? The formula. So, with that being said, how would I calculate the rise? And I want to talk about the fact that on some graphs they clearly identify points. But on other graphs they don't put a point there. When you're picking a point, it's important to pick a point that you can make sure has exact values. You want to pick a point where you can see that it clearly goes through a corner. I wouldn't want to pick this point that's in here, because it misses the corner, doesn't it? Yep. And if I pick any point where it misses the corner, I kind of have to guess at where those numbers are. At this first point that's here, what's the ordered pair that I should put there? 4 and 3. Yeah, go ahead and write it in. On the second ordered pair, 8 and 6. When I go to do the rise, what is it going to be? 6 minus 3, which is 3. When I go to do the run, it's going to be what? 8 minus 4, which is 4. So when I go to do my slope, it's what? 3 over 4. y2 minus y1 over x2 minus x1. By the way, on this particular graph, I wouldn't have done it the long way. This is the long way. Can anybody tell me why I wouldn't have? Okay, but that's counting. That's rise or run, and I wouldn't have done that either. This is what type of relationship? It's proportional. Three over 4 is still what? The same as my slope. 6 over 8 is still the same as what? 3 over 4. If you see that it's proportional, goes through the origin, you don't have to do it the long way. That good? I want you to flip to the homework section and let's look at number 12 together.
Oh, shush.
I promise you, if there's going to be one that you're going to miss on the homework, you're going to miss how to do this if you're not paying attention. It is. It's not, well, it's not proportional, but it is a linear thing. Look, they said a line. I know it's linear, so it has a slope. It has a constant rate of change. Okay? They gave me 2 points that I can calculate my slope from. We're going to calculate the slope from those 2 points. So, if I want to calculate the slope from those 2 points, y2 minus y1, 4 minus 3, over 8 minus 6. The slope is what? 1/2. Because it's a line, I can take any of the ordered pairs and they should have then the same slope, right? So this would say y2 minus y1 over x2 minus x1. And this should be equal to what value? This I can figure. It's what? -6. How do I solve that? I disagree. How would I solve this? Anybody? What do I do? What do we call that? Cross multiply. What's 2 times the -6? If I take 1 times anything that's down here, it's still what was down there, right?
Right.
What am I going to do to get n by itself?
Minus 8 from both sides.
I disagree.
Add 8.
Add 8.
Oh, add 8.
N ends up being what value? -4. Now,
I knew it.
although you said it had to be negative,
I know.
I'm going to tell you, although it came out negative, it didn't have to be. Because this is positive, I know that when I subtract n minus 8, that it had to be a negative when I got the result. But n could have been as large as 7.9 and still turned this into a positive number. So it didn't necessarily have to be negative to start with. That makes sense? I think that's the hardest problem that you have to work on tonight.
Oh, well,
Do you give us the answer?
The question is do you know how to work it back out?
Yes, I do.
yes, I do. I do.